Swayam Prabha. Digital India. Educated India.
We are discussing the grammar of fuzzy sets. So, we will be continuing with the topic Introduction to Fuzzy Sets. Now, at the beginning of this lecture, so we are going to discuss how to solve some numerical examples related to determination of membership value for different types of membership function distribution. And after that, we are going to define a few terms related to fuzzy sets. Some standard operations in fuzzy sets will be discussed. The properties of fuzzy sets will be explained, and at the end, two terms, namely fuzziness and inaccuracy of fuzzy sets, will be defined, and we will be solving some numerical examples like how to determine the fuzziness and inaccuracy of fuzzy sets. Now, to start with the numerical examples related to determination of the membership value, that is mu. So, here let me start with a triangular membership function distribution, and our aim is to determine the membership value, that is mu, corresponding to a particular value of the variable, say x equals to 8.0. Now, here I am just going to consider one triangular membership function distribution. So, this is nothing but the triangular membership function distribution, and if you see, now here I have written a equals to 2, b equals to 6 and c equals to 10. Now, using this a, b and c, so mathematically I can define, so this particular the triangular membership function distribution. This I have already discussed in the last lecture. Now, along this axis, it is the variation of mu, and mu varies from 0.0 to 1.0. Now, here let us see how to determine the value of mu corresponding to a particular value of x, and here we have assumed x equals to 8.0. Now, this mu triangle is nothing but maximum of the minimum between x minus a divided by b minus a, comma c minus x divided by c minus b. So, what you will have to do is, you will have to find out the minimum between these two, and after that we will have to compare this particular minimum and 0 and find out the maximum. Now, here if I just insert the values for this a, b and c. So, substituting the values for a, b and c, we get maximum between the minimum of x minus 2 divided by 6 minus 2, b equals to 6, a equals to 2, comma 10 minus x. So, c is equals to 10 divided by 10 minus 6, comma 0. Now, if we simplify, so this can be written as maximum of the minimum between x minus 2 divided by 4, comma 10 minus x divided by 4, comma 0. Now, if we put x equals to 8, then we will be getting mu triangle equals to maximum of the minimum between. So, x equals to 8 if I put, so this will become 6 by 4, and that is nothing but 3 by 2, and here if I put x equals to 8, this will become 2 by 4, is nothing but 1 by 2. So, what you can do is, so we can find out the minimum between 3 by 2, comma 1 by 2, and the minimum is your half, and now we will try to find out the maximum between half and 0, and that is nothing but half. So, this mu triangle is coming to be equal to 0.5. So, this is the way corresponding to a particular value of x. So, we can find out what should be the value for the membership for the triangular membership function distribution. Now, we are going to discuss what happens in case of trapezoidal membership function distribution. So, once again our aim is to determine the value of this particular the mu, that is the membership function value corresponding to x equals to 3.5. Now, this is nothing but your the trapezoidal membership function distribution. So, this is the trapezoidal membership function distribution. So, here A is kept equal to 2, B is kept equal to 4, C is kept equal to 8 and D is equal to 10. Now, using this information of A, B, C and D, so mathematically you can express so this particular your mu trapezoidal. So, if you see that mu trapezoidal, that particular mathematical expression, so this will become something like this. So, mu trapezoidal is nothing but the maximum between two. Now, the first is actually you will have to find out the minimum among your x minus a divided by b comma 1 comma d minus x divided by d minus c. So, we will have to find out the minimum among these three and then we will have to compare with 0 and we will have to find out the maximum. Now, if we substitute the values for this a, b, c and d, so we will be getting the maximum between the minimum among x minus 2 divided by 4 minus 2 comma 1, 10 minus x divided by 10 minus 8 comma 0. Now, so if you simplify, this will become the minimum among x minus 2 divided by 2 comma 1, 10 minus x divided by 2 and we compare the minimum among 3 and this 0 and we will try to find out the maximum. And whatever you get, so let me just try to see. So, if we put x equals to 3.5, so you will be getting mu trapezoidal is nothing but the maximum between, and before that you will have to find out the minimum among these three, that is your 1.5 divided by 2 comma 1, 6.5 divided by 2. So, the minimum among these three is nothing but 0.75, that is your 1.5 divided by 2 and now we will have to compare 0.75 and 0 and you will have to find out the maximum and that is nothing but 0.75. So, you can find out the value for this mu trapezoidal and that is becoming equal to 0.75. Now, then we are going to concentrate on the Gaussian membership function distribution and our aim is to determine. So, this particular mu corresponding to your x equals to 9.0. Now, this is nothing but the Gaussian membership function distribution. So, if you see, so this is the Gaussian membership function distribution. So, this is the x direction and this is the mu and we know the mathematical expression for this particular the Gaussian membership function distribution, and the mathematical expression for this is nothing but mu Gaussian is 1 divided by e raised to the power half into x minus m divided by sigma square, and m is nothing but your the mean of the Gaussian distribution and sigma denotes the standard deviation. Now, we are going to substitute the values for your m equals to 10.0 and the standard deviation is equal to 3.0. So, we will be getting this particular expression, that is mu Gaussian is nothing but 1 divided by e raised to the power half x minus 10 divided by 3 square, and now we put x equals to 9.0. Then mu Gaussian is nothing but 1 divided by e raised to the power half. So, x equals to 9.0 minus 10.0 divided by 3.0 square, and if you simplify you will be getting 0.9459. So, we can find out what should be the value for this membership function value corresponding to the Gaussian distribution. So, this is how to tackle the Gaussian distribution. Now, we are going to concentrate on another membership function distribution, that is called bell-shaped membership function distribution, and our aim is to determine the value for mu corresponding to say x equals to 8.0. Now, let us see how to do it, and this is nothing but is your bell-shaped membership function distribution. So, this is the distribution and mu varies from 0 to 1. So, let us try to find out the value for mu corresponding to x equals to 8.0. Now, this is the mathematical expression which I have already discussed, that mu bell shaped is nothing but 1 divided by 1 plus mod value of x minus c divided by a raised to the power 2b, and this I have already discussed that the meaning for this a, b and c. Now, here we take c equals to 10.0, and that is actually nothing but the center of this distribution. A indicates the spread of this distribution, and let me consider a is equals to your say 2.0, and b is nothing but 3.0 we have assumed. Now, this b mu bell shaped is nothing but 1 divided by 1 plus x minus 10. So, c is equals to 10 and your a is equals to 2 raised to the power 2b, that is nothing but 6. And if we put x equals to 8.0, so you will be able to find out. So, this mu bell shaped is nothing but 1 divided by say 1 plus the mod value of 8 minus 10 divided by 2 raised to the power 6. Now, 8 minus 10 is minus 2 divided by 2 is equal to minus 1. The mod value of that is nothing but plus 1 raised to the power 6. So, this will become equal to 1. So, 1 divided by 2, and this is going to give rise your 0.5. So, this mu bell shaped is equals to 0.5 corresponding to x equals to 8.0. Now, this is the way actually we should be able to find out the value for the membership function distribution. Now, I am just going to concentrate on another very popular membership function distribution, that is known as sigmoid membership function distribution. Now, this sigmoid membership function distribution is mathematically expressed as follows. So, mu sigmoid is nothing but 1 divided by 1 plus e raised to the power minus a into x minus b. Now, our aim is to determine the value for this mu corresponding to x equals to 8.0. Now, so this is actually the distribution for this your this sigmoid membership function. Now, corresponding to your b equals to 6.0 and a equals to 2. So, I will be getting the expression for mu sigmoid, that is nothing but 1 divided by. So, 1 plus e raised to the power minus a equals to 2 multiplied by x minus b is equals to 6. Now, here if you substitute the value for x, that is your x equals to 8.0. So, you will be getting mu sigmoid is nothing but 1 divided by e raised to the power minus 2 multiplied by 2.0. So, this is nothing but 1 divided by 1 plus e raised to the power minus 4, and that is nothing but 0.98. So, corresponding to x equals to 8.0. So, we are able to find out the value for this particular the mu for the sigmoid membership function distribution, and that is coming to be equal to 0.98. So, this is the way actually we can determine the membership function value for various distribution used for the representing the fuzzy sets. So, till now actually we have discussed, we have defined the concept of fuzzy sets and the concept of your classical sets. Now, to recapitulate the definitions and the difference between the classical set, that is crisp set, and the fuzzy set. Now, let me take another example. Now, this particular example actually is going to tell us what is the difference between the fuzzy sets and the crisp sets more clearly. Now, this particular example is something like this. Supposing that I am just going to invite my friends for today's dinner party, and the time has been given as 7 p.m. for the dinner. Supposing that I have invited a large number of friends. Now, some of my friends will be coming might be exactly at 6:50, some of them may come at 6:55 p.m., some will be coming exactly at 7 p.m., some may also come at say 5 minutes past 7, or some other may come say 10 minutes past 7, and so on. Although I have invited them and I have requested them to come exactly at 7 p.m., so some of them may come before 7 and some other people may come after 7. Now, if you see the concept of the classical set or the crisp set, so this particular distribution indicates the crisp set representation for 7 p.m. So, this particular thing, once again let me tell you, is the crisp set presentation for the classical set or the crisp set. Now, the fuzzy set representation for 7 p.m. is something like this. So, this is actually the fuzzy set representation for 7 p.m. That means, if some of my friend is coming at 6:50, we will assume that like he or she or they have come at 7 p.m. with the membership function distribution 0.33. Similarly, if a friend comes at 6:55 p.m., it is assumed that he has come for the dinner which is scheduled at 7 p.m. with the membership function value 0.66. Same is the situation, like if he comes at 7:05, that means 5 minutes past 7, then we will assume that he has attended that particular party and he has come at 7 p.m. with the membership function value 0.66, and if he comes at 7:10, we will assume that he has come at 7 p.m. with the membership function value 0.33. Now, here let us try to understand. Now, the 7 p.m. as I told has been expressed in crisp set like this. On the other hand, the 7 p.m. in fuzzy set has been expressed by this particular the triangle. Okay. Now, let me try to find out the difference between the classical set and the fuzzy set. So, this is nothing but the crisp set representation for 7 p.m. and this is nothing but the fuzzy set representation for the 7 p.m. Now, my query is which one is more practical? Now, we know it is bit difficult to join the party exactly at 7 p.m. So, if I say that I will have to attend the party at 7 p.m., so this particular the distribution for 7 p.m. that is the crisp set representation is bit difficult to achieve, whereas the fuzzy set representation for the 7 p.m. it is little bit easier to achieve, and that is why the fuzzy set representation for the 7 p.m. is a more practical way of representing the time, that is the 7 p.m. So, let me conclude that fuzzy set representation could be more practical compared to the crisp set representation for the 7 p.m. So, I hope you have understood the difference between the representation of crisp set and this particular the fuzzy set. Now, I am just going to concentrate on a few terms which are very frequently used in fuzzy sets, and I am just going to define those terms, and I am just going to solve a few numerical examples also. Now, the first term which I am going to define related to fuzzy sets is very popular, that is known as the alpha cut of a fuzzy set. Now, supposing that I have got a fuzzy set which is denoted by A x. Now, its alpha cut is represented by this alpha mu A x. So, this is nothing but the alpha cut of a fuzzy set. Now, the value for this particular alpha, so this will vary from 0.0 to 1.0. Now, if I insert a particular value for this particular alpha, for example, say alpha equals to say 0.7. So, truly speaking, I am just going to find out what should be the 0.7 cut of a particular the fuzzy set. Now, let us see how to define. Now, this alpha cut of a fuzzy set which is represented by alpha mu A x is nothing but x such that mu A x becomes greater than equals to alpha. So, this is actually the definition for this particular the alpha cut. Now, I am just going to take one example just to tell you what do you mean by this particular the definition of alpha cut. Now, let me assume that this particular triangular membership function distribution is going to represent a fuzzy set, and that is nothing but A x. So, A x is going to represent a fuzzy set and its alpha cut I am just going to define. Now, supposing that the alpha is here, say 0.4 or 0.45, something like this. Now, corresponding to this particular alpha, so you draw one line here. So, this is the line and it is going to intersect at this particular point and at this particular point. Now, corresponding to this particular point, so you try to find out the value for this x. Similarly, corresponding to this particular point, you try to find out the value for this particular the x. And according to the definition of this particular alpha cut, the alpha actually this mu A x should be your greater than equals to alpha. So, this is the value of alpha. So, more than alpha means I am here. Okay. So, either alpha or more than alpha, and if I just follow that, so I will be able to find out the subset of this particular your fuzzy set, and that is nothing but this. So, this is known as the alpha cut of this particular the fuzzy set. So, this is the way actually we can define the alpha cut of a particular the fuzzy set. Now, another term I am just going to define here, and that is known as the strong alpha cut of a fuzzy set. Now, by strong alpha cut of a fuzzy set, we mean it is alpha mu A x plus. So, just to indicate the strong alpha cut, we take the help of this particular symbol of plus, and by definition this is nothing but x such that mu A x is greater than alpha. So, this is actually the definition of your the strong alpha cut of a fuzzy set. Now, we are going to solve one numerical example just to make it more clear. Now, the statement of the numerical example is as follows. The membership function distribution of a fuzzy set is assumed to follow a Gaussian distribution with mean m equals to 100 and standard deviation, that is your sigma is equals to 20. Now, determine 0.6 cut of this particular the distribution. So, I have got a membership function distribution which is nothing but Gaussian and whose mathematical expression is nothing but, so mu equals to 1 divided by e raised to the power half x minus m divided by sigma square. So, this is nothing but the membership function distribution for this particular your the Gaussian distribution. Now, where m is nothing but the mean and sigma is the standard deviation. So, what we do is we substitute the values for mu. So, mu is equals to 0.6, the mean m equals to 100 and standard deviation sigma equals to 20. Okay. Now, let us try to find out like what should be the value for this mu. Now, what you do is you substitute the values for the mu, m and sigma, and this is nothing but is the Gaussian membership function distribution. So, this is the Gaussian membership function distribution with mean equals to m. Now, if you substitute the values, so this will become mu equals to 0.6 equals to 1 divided by half e raised to the power half, so x minus 100 divided by 20 square, and if you simplify, so this will become e raised to the power half x minus 100 divided by 20 square, and that is equals to 1 divided by 0.6. Now, we can take log on both the sides. So, ln, that is log base e. So, e raised to the power half x minus 100 divided by 20 square is nothing but ln 1.6667, and if you simplify, so we will be getting the values for x like I will be getting 79.7846 and 120.2153. Now, if I just plot, so on this plot if I just indicate the values, so this is nothing but 79.7846 and this is nothing but 120.2153, and here, so you will be getting one range for this particular x. So, this is nothing but is your 0.6 cut of this Gaussian distribution. So, this is the way actually we will be able to find out the alpha cut of a particular the fuzzy set. Now, we are going to define another term, and that is known as support of a fuzzy set. Now, let us see what do you mean by the support of a fuzzy set. Now, by definition, support of a fuzzy set A x is nothing but say x belongs to the universe of discourse, that is capital X, such that mu A x is greater than 0. So, this is what we mean by actually the support of a fuzzy set. So, mu A x is greater than 0 if I consider. Now, let me try to consider, say this is a particular say the fuzzy set. So, the triangular membership function distribution if I consider. So, this is nothing but A x. So, mu is actually along this direction. So, this is 0.0 and corresponding to this is 1.0. Now, let me try to read the definition once again. Support of a fuzzy set A x is nothing but x belongs to capital X, that is the universe of discourse, such that mu A x is greater than 0. So, corresponding to this, so mu is equal to 0.0, and if I consider that mu is greater than 0, so as if I am just going to touch, I am just going to indicate the limiting value for this particular x, and this is going to indicate the support of a fuzzy set. And here you see x belongs to capital X. So, this is nothing but x. So, x belongs to capital X, that is universe of discourse, and this particular condition holds good, that is mu x is greater than 0. So, this is going to indicate the support of a fuzzy set. Now, the next is the scalar cardinality of a fuzzy set. So, by scalar cardinality we mean that mod value of A x. So, A x is nothing but the fuzzy sets, and its scalar cardinality is denoted by so this particular symbol, and that is nothing but is your summation x belongs to capital X mu A x. So, this is nothing but the collection of all membership function values. Now, I am just going to solve one numerical example just to find out the scalar cardinality of a particular the fuzzy set. Now, let me assume that so this is nothing but a fuzzy sets having say the discrete values corresponding to the 4 values of the elements. So, Ax is nothing but x1 comma 0.1, x2 comma 0.2, x3 comma 0.3, x4 comma 0.4. So, this is nothing but a discrete fuzzy set. Now, its scalar cardinality is denoted by, so this particular symbol, and that is nothing but the sum of all the mu values. That means, here we have got 0.1 plus 0.2 plus 0.3 plus 0.4, and this is nothing but 1.0. So, 1.0 is coming as scalar cardinality of this particular the fuzzy set Ax. Thank you. দেবাশিস, তুমি জাস্ট নেক্সট ইয়েটাতে চলে যাও তো, পাশেরটাতে। হ্যাঁ।